Okay guys, this is section 2, part 2. This is kind of unedited in a way, so it's about a half-hour long. You can kind of scroll through some things that you need to scroll through. So, here you go. Here's an example for you. Let's keep it simple yet a little bit complex. We'll do the fifth root of 3 to the 3 divided by 4. Fifth root of 3/4. So I'll keep it simple for now. You figure out. Yeah, nobody can. Ready? Here we go. Break it up. Fifth root of 3 doesn't simplify. Fifth root of 4, I could write 4, but I'm not going to. A lot of people, I bet, left 4. You wanna break numbers down, right? I don't want to leave 27. I want 3 cubed. I don't want to leave 8. I want 2 cubed, whatever it is. So 4 is 2 squared. Why could you do it with 4? You could, but then in the end, whatever your final answer is, that's going to simplify. So you don't want to simplify that answer. It's too big, but it can simplify. So do this. Make it 2 squared. If you didn't do 2 squared, I would write this down with me. Now, could you simplify the top? No. Could you simplify the bottom? No. Which means we're going to have to do what? Rationalize. Question is, here's the key. What do you rationalize by? The fifth root of 2 to the 2 to the third, 2 cubed. Why? Because you wanted the fifth root of 2 to the. That's what you want. That's why I have 3 here. We already have 2. You want 3 more, which makes 2 to the 5th on the bottom. Perfect. If you got that, good job. Fifth root of 2 cubed up top. So multiply up top. Fifth root, we can multiply. 3 times 2 cubed, which is 8. So, fifth root of 24 up top. That doesn't simplify, but the bottom does. 2. Fifth root of 24 over 2. How many people actually got that? Not bad. Pretty good. Pretty good. Yeah. Alright. If you want to do this one, a couple ways to do it. If you want to do 54 to the 1/3 over 64 to the 1/3. I like to change it back and forth. This, sometimes I like to just look at it like this for some reason. 54, oh, cube root of 54. What's the cube root of 54? Anybody know?
I don't know.
Okay. What about the cube root bottom? Cube root of 64.
The 4.
That's equal to 4. Up top, you do it off to the side, right? What are some cubes within 54?
27.
27 is a cube within 54. 27 and 2. This is how you break them up, right? So the cube root of 54 is the same as the cube root of 27, cube root of 2. Cube root of 27 is 3, because it's a cube. So 3 cube roots of 2 on top. So 3 cube roots of 2. Okay? Good with that?
Yes, sir.
Alright. Moving on then. On with the section 2. More. I'm just going to do the rest of the class, section 2. Alright, so here's the question, real quick. We did something like this a little bit earlier. Just to make sure though. Fifth root of 7, fifth root of 8. I don't know why I wrote it again, but you can't simplify fifth root of 7, can't simplify fifth root of 8. But that's why I think of it as 2 cubed and not 8 anymore. Because, so I know what to multiply by. See what they multiply by? The fifth root of 4, which is really
2 to the second power.
2 squared. You see why they did that? Fifth root, 2 cubed, 2 squared, makes it the fifth root of 2 to the 5th so that you get 2 in the bottom. You understand that? If you can understand that concept, you're in good shape. If you still don't get that, come see me. We'll do some more problems. Okay. The book doesn't show this. Like, they don't show you me breaking it down like this and this. I just think it's easier to think of it like that. So they just say 8 and 4. And you have to know your cubes. You have to know your fourth roots, fifth roots, all those. So it's up to you, though. I don't care how you do it as long as you get the right answer. Alright, example 5. Just adding and subtracting, basically, it'll get harder later. What is the 4th root of 10 plus 7 4th roots of 10? It's not as hard as you think it is.
8 4 roots of 10.
That's like x plus 7x. 8x, right? 8 4th roots of 10. Now, can we simplify 4th root of 10? Is there any 4th roots within 10?
No, sir.
10 is just 2 times 5. So, should we rationalize?
No.
Why? Why, Joe?
Can't.
Why not, Sam?
Because that's not a fraction.
Because it's not a fraction. I'll get people who will try to multiply by stuff. It's not a fraction. It's not in the denominator. Okay? It's done. That's all you can do. Okay, next one. 2 8 to the 1/5 plus 10 8 to the 1/5.
Under 12.
Yeah, that's like 2 x's plus 10 x's. Same exact thing. So, 2 plus 10, 12, 8 to the 1/5. That's called my voice. Okay? Listen to it. She said, "What's that noise?" I said, "That's my voice." Start listening. Alright, you get the picture. Now, C is more like the problem that I'll give you, but this is still a little bit on the simple side. Something basic you have to know is how to break things down. Can you break down cube root of 54? I hope so. Cube root of. Cube root of. What's a cube within 54? 27. Cube root of 2. Everybody get that? 54. Cube root of 27. Cube root of 2. Minus cube root of 2. What's cube root of 27? 3. 3 cube roots of 2 minus a cube root of 2. Which is? That's like 3 minus 1. Which is 2 cube roots of 2. Everybody understand the logic behind what we're doing. Know how to break things down. Okay? Break them down into cubes. What if that was a 4th root? Then you'd be trying to find 4th powers within 54, which probably aren't any. Okay? So that's how you have to think. Any questions on example 5? Alright. Example 6. Alright. Simplify. Now they say assume all variables are positive. You don't have to worry about that statement. They're just kind of being more specific because if the variables were negative, we'd have a couple answers. We want to keep things simple. We just want to assume that they're all positive. So here we go. How do we approach this problem like this? Sam?
I think you should first change it, the format, I think, to the bracket, to the rational exponent.
Okay, he says change the radical to rational exponent. You can. That's good. You can always do that. You can always go back and forth. It's the same thing. If that's easier for you, do it. It might be easier in this case. Let's do it. 64, y to the 6, all to the what power?
1/3.
1/3. Everybody know that the cube root is the same as 1/3 power, right? I hope. Now look at this. Use your laws. 64 to the 1/3 and y to the 6th to the 1/3. What is 64 to the 1/3? Or what is the cube root of 64? 4. What is y 6 to the 1/3? Use your power to a power.
Y.
This times this. Y squared. And you are done. Over. Okay? Now, what's another way to pull this off? Just break it up. Look. The cube root of 64 times the cube root of y to the 6th. Now, if I do it this way, here's the trick on these ones. If you ever see stuff like this, like y to the 6th to the 3rd root, change it back. What is that the same as? Y to the this and this. The index goes on the bottom, right? This goes on top. Y to the 6/3, y squared. You understand? So if you get this, I just change them back and forth. Okay? Understand what to do. There's 4y squared. Still get the same answer. Any questions on that one? Alright. So, know how to break things apart and then kind of put it back together. Try the second one here. Easy. I'm not going to give it to you this easy. Look what happens. Let's break it apart. 27 to the 1/3 power. How much is that? 3, right? The cube root of 27. That's what that means. That's 3. P to the 3rd to the 1/3. P. Q12 to the 1/3. Q to the 4th. You know, everybody know what we did. We just took this power to this power. That's 4. We took this power to this power. That's P to the 1st. We took this power to 27. 27 to 1/3 is 3. Done. I'm not going to give it to you that easy. Alright? Okay? But you have to know that to do the hard ones. So, here we go. Let's see if there's a harder one. Same thing. Too easy. Let's do it together. Let's break it apart. The 4th root of m to the 4th. The 4th root of n to the 8th. What's the top equal? M to the 1st. What's the bottom equal? N squared. Too easy. No work. 2 seconds. See if there's a harder one. This one's decent. It's decent. Let me change one thing to make it a little better. I'm going to make that y to the negative 1/3 power. So, see what you can come up with, knowing all that you know. If you didn't get it, let me show you. 14 over 2, we can do that right away. 7. Let's do each of these ones individually. X over x to the 3/4. I'm just going to write it here. Let's do it individual. Don't look at all this at once. Just do this. What is x divided by x to the 3/4? Use your rules.
X to 1/4.
X to the 1/4. If I do 1 minus 3/4, there's 1/4. So far I got 7. X to the 1/4. Let's do y. Well, there's only one of them. What happens when you have a negative exponent? What are you going to do with it?
Flip it.
Flip it down. So let's put it down. 1 over y to the 1/3. Everybody get that? There's another one. Done. Z to the negative 6, same thing. Flip it up. So you got z to the positive 6 over 1. See how it flipped up? All you have to do now is put all those together. This, 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 and this. So you get 7 on top, x to the 1/4 on top, z to the 6th on top, over y to the 1/3. Anybody have that answer? Wrong. What?
Do you have to put it in a radical form?
That's what I was saying.
Okay, now she said put it in a radical form. Here's my rule of thumb. If you start out with rational exponents, you want to end with rational exponents. If you start out with roots like this, end with roots if you have to. You understand? Is it wrong to have changed these to radical? It's not wrong. I keep a rule of thumb, so I don't have to have 2 answers for every test question. Okay? Easier on me. Okay? But this is not the answer. Why is this not the answer? Y to the 1/3 really means cube root y, which means there's a radical down below. You cannot have a radical down below. So make a note here. If you get fractional exponents in the denominator, you're going to have to what? Rationalize them. So question is, I'm going to write this on a new screen. Question is, how do you rationalize, what was it, 7x to the 1/4, z to the 6th, all over y to the 1/3. Let's change the form. you can 7z to the 6th, and that means the 4th root of x. That's fine. Same thing. Y to the 1/3, cube root of y. You guys all know how to rationalize, I hope, by now. So what do we rationalize by? The cube root of y squared, right? So we can have the cube root of y to the 3rd. That's what we want. So the cube root of y squared up top, cube root of y squared in the bottom, which becomes 7z to the 6th. 4th root of x, 3rd root of y squared. We don't want to put those together. See how the roots are different? You don't want to put those together. So I'm going to change the forms back again. X to this right here. I'm just going to say x to the 1/4. Y to the what? 2/3. All over. What does this become on the bottom? Cube root of y cubed, which is y. Everyone understand what it is? All I did was rationalize. Cube root of y squared. Because this was the cube root of y. I needed 2 more. So I just multiplied that to the top and the bottom. And then I just rewrote it. The bottom becomes y, the top becomes... I just changed this back to rational. Jerry?
Do we have to simplify when there's because there's y and they're all
Yeah, good question. You see y to the 2/3 y, so you think, oh, y divided by y. But if you did simplify, you'd be coming back to y to the 1/3 again. So you want to leave it. That's not rational. That's irrational. So that's why we did this, to make it a rational y down here. So good thought, but we want to leave it here. Everyone understand how we rationalize the denominator? Okay. What else? Oh, the other way to do this. I want to show you the other way. Maybe this is easier for you. I like to actually do it the other way. I think it takes less work. So watch what I do here. What else? Instead of changing it to radical form, like cube root of y, all I have to do is multiply by y to some power, and I get what I want. What power would I multiply? If you know your rules, if you multiply by 3, I see why you're doing that. But if you did it, how do you multiply y? Let's see, y to the 3rd times y squared. What do you do with those? Add them up, which would be y to the 5th. So y to some power 2/3, which some people are saying and figuring out. What's y to the 1/3 times y to the 2/3? Y to the 1st. No more radical. You understand? So you could do it this way. If you understand this way, do it this way. Y to 2/3, y to 2/3, which makes y on the bottom. You understand that? And then you got the whole top here. Okay? So a couple ways to do it. Your choice. I'm not going to tell you which way to go. You choose. Alright. Let's finish up what we're doing here. Example 6 is done. Example 7, here we go. Write variable expressions in simplest form. Once again, assume all variables are positive. Just start simplifying. Now, how do you simplify something long like this? You break it up. Okay? Break it up, break it up, break it up. And then do it individually. This one, do individually. What is it? Do this one individually. What is it? Okay? That's why you have to do these ones. Go ahead. I guess I'll start you off. Let's just break it up. The 5th root of 4, 5th root of A8, 5th root of B to the 14th, 5th root of C to the 5th. And all you're going to do is just simplify this if you can. Sometimes you can't. This one you can't. This one you can. You can simplify all of these right here. And then in the end, bring it all back together. Go ahead. See what you do. Alright, let's do it. Here we go. 5th root of 4 doesn't simplify. Leave it. 5th root of 4. 5th root of 88. It's kind of like this. What is square root of 10? Square root of 10 is square root of 5, square root of 2, even though those don't simplify. You understand? This is the same thing. This you want to break down into two things. The fifth root of something times the fifth root of something. What would be nice to have? A to the fifth. I mean, a to the eighth is a to the sixth, a squared, a to the first, a to the seventh. Could be anything. You want a to the fifth. And then how many's left? 3's left. See? A to the fifth, a to the third. Why do we do that? Because this simplifies again. Okay, next one. B to the 14th. Break that up into two things, or three things if you want to. What is B to the 14th? B5, B5, B4. You can do three things. You can do as many as you want, really. Or you can just do B10, B4. It's up to you, however you see it. Whatever you want to do. So look, I'm going to do B10. So the fifth root of B10 and the fifth root of B4. Everybody get that? B to the 14th, B to the 10th, B to the 4th. Why B to the 10th? Because, look, 10 divided by 5, B squared. Works out nice. You have to think like that. You have to think, what's going to work out nice for me? All right? You can't just pick any numbers you want. So B squared times fifth root of B to the 4th. You can't simplify that. You leave it. Fifth root of C to the 5th. C. No, we're not saying Spanish. Okay. Fifth root of A to the 5th. A. Fifth root of A cubed is left. And then the fifth root of 4. Now look at all these roots. Root, root, root. Put them all together. Make one nice one. So we got A out front. We got B squared out front. And we got C out front. Times the fifth root of all these roots. We got 4. We got A cubed. And we got B4. Everybody see what I'm doing? If you understand, you're good. Alright? Know how to break something up that's long like this, even though that's not that long. Okay, break it up individually and then see what happens. Any questions on this one? Okay, let's do another one. By the end of today, I hope you say, no, I'm good, I understand, and you're not like, I have no idea what you're talking about. Alright, next one, letter B. You do this one. Here we go. Break it down. See what this broke down to. Cube root of 2 doesn't break down. Cube root of Z to the 5th does break down. Cube root of Z to the 3rd. Cube root of Z squared. Everybody get that? Understand my logic behind all this. 12 out front. Minus. I'm just going to break it all down at the same time. Z. Cube root of 54. And the cube root of Z squared. So what does this become? Cube root of Z cubed is Z. So we got 12Z. We got these two left over, so cube root of 2Z squared. Everybody should have that on their paper. Next one, cube root of 54 is cube root of 27. You already done this today. Cube root of 2, which is 3. And then we had a Z here. 3Z. So those are taken care of. You got to be careful with doing this kind of stuff. It's messy. This is taken care of. So really we have cube root of 2 Z squared left here. So you should have 12Z cube root of 2Z squared minus 3Z cube root of 2Z squared. It become the same thing. So 12Z minus 3Z, 9Z cube root 2Z squared. Anybody get that answer?